All right, I think that's recording. Hi, everyone. Welcome to Late Night Microeconomics. It's currently, just past midnight, so it's not that bad. But I'm just sort of winding down for the night, so I haven't got my camera on this time. Anyway, this is problem set 5 for microeconomics. We're going to be going over all the questions from it. I don't know if it's due on Saturday or not, but I just thought I'd cover it now just in case. But yeah, we're going to get into it. So first of all, let's look at our first question here. Okay, we want to consider the model of insurance described in class. I can't read. Suppose that the buyers just come in two types, those with pi of 0 and those with pi of 1. So we're talking about some people who never have accidents and some people who will always have an accident. We're replacing it with half on 0 and half on 1. There we go. I think that should be on and not 1. I'll get them to edit that. Okay. What price for insurance will get both times to buy it? Well, none. Nothing will work here. Okay? Think about it. If you have no chance of ever being in an accident, why would you buy insurance at any price? Okay? The only price you would ever possibly buy it at was when it would be free, in which case it's technically not insurance anymore. Likewise, if you know you're going to have an accident, then you know you're always going to get paid out. And so the company won't supply it. So it's kind of weird. Can firms make a profit at this price? Well, no. With the completely no-risk people, they'll break even, okay? They get no money, the company gets no money, they break even, right? But if we're looking at the high-risk kind of always getting in an accident kind of people, these people are always going to make profit, and the company is always going to make a loss. Think about it. When we understand, and this is in the second set of slides, that the price is going to be roughly, hold on, where is it? Price in perfect competition, yeah. The price in perfect competition when it comes to insurance is this. The price is equal to the loss times the riskiness, pretty much. In a perfect competition where we don't make zero, we make zero profit, yeah? So if our pi is 1, then our price is our loss, right? But the thing is, if I'm paying the price which is equal to my loss, I'm going to expect more than that for when I'm actually getting reimbursed, right? Because I'm not going to settle for, okay, I'm paying my loss and then I get less for my payback. No, that wouldn't work. So I'd have to get paid more than this, okay? Which just won't work from the company's perspective. So they'd make a loss in that case. And finally, what's the equilibrium in the market and who ends up buying only pretty much only the low-risk people will end up buying insurance. And only the I made a mistake. Only the high-risk people will end up buying insurance because they are going to make a profit. The low-risk people, they're not going to buy it. They're kind of indifferent between it. They can leave it. They can take it. But the thing is, they're not going to be available to have it because the price is going to be set for the high risk at P equals L. So only the clients that only have accidents will buy the insurance because they'll make their money back. That's the case. Okay, on to 2. Now 2 is much more complicated. Okay, it requires a lot more calculation and stuff like that. Now I know that we all thought we were hot shit when we basically got a maths A level or something related to maths, and we think, oh, we can do all the maths in the world. And then you've gone through 2 years and now you realize that you're just shit at it. I completely understand. But okay, let's first of all start with this function. H of P. Now we understand H of P as, where is it? Yeah, H of P. Think of this as the cutoff for the people who will buy and the people who will not buy. Okay? Not bisexual, but you understand what I mean. So we need to show that this function is, show that, I assume that it means HP is increasing or just H. Show that this function is increasing and convex in P. Okay? Now, to show it's increasing, we've got to obviously show that its first derivative is always non-negative, or, if you'd like, always positive or equal to 0. Okay? Non-negative is easier, just because we're saying it's never decreasing, pretty much. Convex also technically is the same thing. It always has to be positive, or non-negative rather. Remember, positive and non-negative are the same things. Positive means it's above 0. Non-negative means it's above 0, including 0. Okay, so we're going to calculate this. Okay, first of all, what I did is I made it into a nice simpler form. So first of all, I take the bottom here, and I move it to the side, give it a nice little minus there, because the 1, just 1 to the power of minus 1 is just 1. We just leave that as that. Then what I did is I expanded this out, a bit like a quadratic, okay? So you've got these terms here, right? And then if we derive all these terms, okay, with respect to p, remember, if it's respect to p, then we remove the constants, like this one and this one, and we end up with something like this, okay? And by the end of that, you should end up with an expression that looks like this. Hopefully you guys got that. I'm just going to check I'm recording still. Looks all good. Okay. So now we've got this one. Okay, this is always going to be increasing. Why? Now, you've got to think about P and W in relation to P and L in relation to W. The price and the loss can't really exceed the amount of wealth you have, because if the loss exceeds the amount of wealth you have, then you're technically bankrupt. And if the price exceeds the amount of wealth you have, then you just can't pay for it, really. So we know that P and L are going to be smaller than W, which means these fractions are going to be smaller than 1 in both cases, which means these brackets will be positive, right? And that means also this bracket will be positive, which is good as well. So all of our terms down here are positive, including W, of course. Wealth we're assuming to be positive because I don't really know too many people who have negative wealth, apart from the average student. Anyway, so, yeah, we've got this derivative. The bottom term's lovely and neat. That's good. So now to find the second derivative, okay, I'm going to separate out the p from this. So you kind of separate it out into little bits. And then once I derive the p, I slot it back in and we get something that looks like this, okay? Feel free to pause to take a look at it. There's also the notes in the description, so feel free to take a look at those. Hopefully that'll help you guys out. Then we also have, okay, so those are basically the proofs for first derivative is always non-negative and second derivative is always non-negative. You can see from this one, it's obviously still going to maintain the same stuff we said before, so you don't really need to rewrite too much, okay? Now, calculate the slope of 1 plus hp over 2 when p equals L, okay? Now, functionally, we don't need to redo our function and then redo a derivative. Think of it like this, okay? When you have a derivative there, what happens? Well, functionally, any constant gets factored out. So this 1 is just going to go away. But that dividing by 2 bit, well, that's going to stick around, right? Because it doesn't, because that's a constant, that's something we're timesing by it, it doesn't really get factored out because it's just on the function. So that's going to stay around, okay? So think of it as sort of just taking this one here, this slope coefficient, and we're just going to times it by 2. And that is pretty much it, okay? And now if we replace p with L, we're going to get this. So the point is to essentially remove the p, which is the variable thing here, and just put it in terms of L. So it's just one big constant. So this is the slope coefficient. It's 1 over 4w, bracket 1 minus L over w to the power of a half, bracket 1 minus bracket 1 minus L over w, bracket half, bracket. It's a lot of brackets. You get the deal. I don't know. I thought of simplifying 1 minus L over W down to a single letter, which you can do, and I think it would probably make it easier, like if I said like 4wx to the power of a half, 1 minus x to the power of a half. It could be easier, but you may have to declare it. I don't know. I didn't really bother. Okay, use the facts you've described above to explain under what circumstances there is an equilibrium where more than 0 high-risk individuals buy insurance. Now, what have we done here? So, some of you may recognize this little function here, 1 plus hp over 2, because this is a function that calculates the average buyer riskiness. As you can see here, average buyer riskiness is a half times 1 plus hp. So, average buyer riskiness, right? You may also remember this function here, loss times average buyer riskiness is equal to the price, right? Now, we see here that we get equilibriums where these two lines meet, right? And often, sometimes they just meet at the loss, but sometimes they meet twice, okay? Where they go under and then over, right? Now, this is the slope coefficient, okay? The slope coefficient, which is very important. We can say that, okay, and what does it ask? There is an equilibrium where more than 0 high-risk individuals buy insurance, okay? That kind of equilibrium is what we're seeing here. It's 2. One at loss price and one at under the loss price. This is the sort of like perfect competition one where we're setting price equal to loss. And this is sort of the other one where some other people are also going to get in on the deal because their sort of losses, well, the average loss here is basically aligning. Okay, so how do we know if this is the case? Well, a very important thing. See how this sort of curves underneath, okay? Think of it coming back up to meet the line, okay? For this line to come back up to meet the line, the slope has got to get steeper than 1, hasn't it? Okay? Because if it's under 1, it has to go back over 1 to catch up. Sort of like this. So fundamentally, our slope coefficient for our sort of blue line here is going to have to be larger than 1 at some point. Otherwise, it's just not going to work. So this is our condition. We times it by L, because remember there is an L here, and we're going to just take our slope, times it by L, and that must be larger than 1, okay? And that is the condition which stipulates that there's going to be an extra point there, okay? Now, you don't have to calculate exactly the coordinates of where it's going to be. I don't think it asks you that. Just explain under what circumstances, and I've provided a condition, so that's the circumstance. Okay, now on to the challenging one. Again, consider the insurance model of adverse selection described in class. Ugh, how boring. I've done this little one here. Suppose that consumers have a density... Dear me, I've got a density right now. Suppose that consumer types have a density of function of pi is equal to 2 pi on the interval 0 to 1. Okay, that's the deal. Calculate this equilibrium insurance contract as price P star and who buys insurance at this equilibrium. Now, this one I'm not completely sure about, so feel free to criticize me about it, okay? Because I'm not completely sure, okay? Just keep it light, okay? So, first of all, the important bit to recognize here is, first of all, it's good to generally get the area, which is the demand for the product, at the start, okay? This is going to be the area between 1 and HP underneath the curve, okay? Now, given this curve is represented by 2 pi, okay, and we want the area underneath between two sort of points, we can use an integral, right? It's going to be the integral between HP and 1 of 2 pi d pi. Now, obviously, that's going to be pi squared between those two, and then you calculate it, you get 1 minus HP, okay? Now, here comes the tricky part, okay? How do we actually get the average riskiness? Because average riskiness is important for determining the price. We already sort of saw that. It's loss times average riskiness equals the price, pretty much. So how do we get the average riskiness? Well, it's tricky. Now, I'm not sure if this is right, but I'm going to go for it, okay? So to do that, we're going to sort of divide the total area sort of under the curve, not just the bisection, the total area under the bicurve, by just the bisection, okay? And this is sort of just calculated as pi times 2 pi, as sort of just like the total possibilities of probabilities times the curve, okay? I'm not entirely sure if this is correct. Feel free to correct me. But yeah, that's what I kind of got. Then we set that equal to the integral. We do that. And then we get our sort of result, which is 2/3 minus 2/3 HP cubed. That's our kind of finish there. Now, to actually get the average riskiness, we kind of need to divide these two. Noticeably, you're going to have to divide the total by the actual bisection to get that kind of, proportion that we want there, the proportion of average riskiness that you'd get. And this expression sort of represents that. And now, because we have average riskiness, we can plug that back into our sort of price times loss times average riskiness. Price is equal to loss times average riskiness. And voila, that is it. But that is it, pretty much. I'm not entirely sure if my process was right. It did sort of, like, it'll take too long to really explain it, but the point is that the proportion works there. So the proportion necessarily within your curve works because the proportion is equal to the average riskiness level. At least that's how I saw it. Anyway, for question 4, this one's quite easy, so I don't think this will take too long. Explain what insurance companies can do to get individuals to reveal their riskiness. So you see, what insurance companies do is that they make people go onto this like massive, like assault course, a lot of paintballs, like these big, like floating panels, like Wipeout style. And then if they get through, they determine their insurance score. It's a very interesting process, really. And I'm obviously bullshitting you. Sorry. Okay, generally you might want to mention here screening, just sort of talking about people's age, health habits, other factors. Like you could talk about, do you smoke? Are you currently pregnant? Are you planning on having kids? Are you, for example, I don't know, a civil engineer, perhaps? A very risky career. But yeah, like stuff like that. Just asking them about their lives, okay? The problem is with this that individuals may pick information that is false to get maybe a cheaper premium, okay? So for example, if I was a smoker and I did a lot of risky things, I would pretend that I didn't. So I wouldn't have to pay much on a premium for insurance. However, that would technically be lying. There are ways insurance companies can, catch you out about this, but we're not really taking that into account yet, so it's okay. So you have moral hazard here, adverse selection, because people who are very non-risky won't really buy insurance, and and the company just doesn't know. So that's going to be asymmetric information as well. Okay, I think that's it. Hopefully that was helpful. I bloody well hope it was. I tried to go through it fairly quickly. Oh, it's only been 17 minutes. Okay, that's good. But yeah, that's the deal. I'll put these notes in the description. Oh, also, the exam is coming up, right? There's an exam coming up on the 13th on microeconomics, so less than 2 weeks away. Nervous. I'm going to try to make like a nice little sheet just to make it a little easier. I'll try to do like a revision video or something. We'll see what happens. I'll be busy myself, of course, but I'll try to make something for you guys just because I know, like, you guys are struggling just as much as I am, and I'm sure you'll appreciate it. Okay, I'm going to go. I kind of have to go to sleep, but yeah, I'll see you guys around. Okay, bye.